Good morning. Myself, Dr. Kuncham Narasimhulu, Assistant Professor of Physics. This is a government first aid college, Autonomous Ballari. Today, let's discuss about frames of references, problems, and activity. Problem 1. Calculate the velocity of the rod when its length will appear 90% of its proper length. You can find out that velocity of rod. Solution: L is equal to L into 1 minus V square by C square whole power 1 by 2. Therefore, L is nothing but 90 is equal to 100 into 1 minus V square by C square whole power 1 by 2, or 1 minus V square by C square whole power 1 by 2, that is equal to 0.9. So 1 minus V square by C square is equal to 0.81, or V square by C square is equal to 0.19. Therefore, V square is equal to 0.19 C square. Therefore, V is equal to velocity. V is equal to square root of 0.19 into C. C is nothing but velocity of light. Then multiple of square root of 0.19 into 3 into 10 power 8. That is equal to, finally, the velocity of rod is 1.307 into 10 power 8 meters second power minus 1. Problem number 2. A moving particle has coordinates 6t plus 3, 8t and 5m in frame S at any time t. The frame S dash is moving relative to S with velocity 3I plus 4j meters per second. Find the coordinates of the velocity of the particle in frame S dash. So given the data, frame S coordinates, x coordinates 60 plus 3, y coordinate 80, z coordinate 5m, and velocity of second coordinate with reference to relative to the first reference frame of reference. X velocity x is equal to 3, velocity y is equal to 4. So solution: Galilean transformation equation for space coordinates are x dash is equal to x minus vxt, y dash is equal to y minus vyt, and z dash is equal to z minus vzt. Now x coordinates in the frame of reference is x is equal to 60 plus 3, comma, y coordinates is equal to 80 and z coordinate is equal to 5. Similarly, frames S dash is moving relative to S with velocities Vx is equal to 3, Vy is equal to 4 and Vz is equal to 0. So equation of space coordinates x dash is equal to x minus Vxt, x is equal to, that is equal to 60 plus 3 minus 3t, that is equal to 3t plus 3. Similarly, y dash is equal to y minus Vy into t, that is equal to 8t minus 4t, that is equal to 4t. Finally, z dash is equal to z minus vzt, that is equal to 5 minus 0, that is velocity axis, z axis is equal, there is no data, that value is 0. 5 minus 0 is equal to 5. So therefore the coordinates of the particle S dash are 3t plus 3, 4t, 5. So velocity x dash is equal to 3t plus 3. Dx dash by dt dash is equal to dx dash by dt into dt by dt dash. Yes. Finally, dx dash by dt. Hence, dx dash by dt is equal to 3, or ux dash bar is equal to 3i. That is velocity of uh, x-axis is equal to 3i. Similarly, same thing, dy dash by dt dash is equal to dy dash by dt is equal to 4. So uy dot r is equal to 4j. Similarly, dz dot by dt is equal to 0. Therefore, velocity in frames s dash is equal to u dash bar is equal to the combination of velocities x-axis, y-axis and z-axis, that is ux dot bar, uy dot bar plus uz bar, that is equal to 3i plus 4j. Problem number 3. An electron is moving with the speed of 0.85 c in a direction opposite to that of a moving photon. Calculate the relative velocity of the electron and photon. So given the data is speed, that is 0.85 c, that is a negative, opposite is nothing but negative. The speed of the photon is equal to c, the speed of the electron is equal to 0.85 c. Let the photon and electron be moving along positive and negative direction of x-axis respectively. Let the electron moving with velocity minus 0.85 c be at rest in a system S. Then we may assume that system S dash or laboratory is moving with the velocity 0.85 c related to the system S. Then we may write V is equal to 0.85 c. The velocity of x coordinate is equal to c. So ux is equal to ux dash plus v by 1 plus ux dash v by c square. That is c plus velocity of x is equal to c and velocity is equal to 0.585 c by 1 plus 0.85 c by c square. Finally, that is c plus 0.85 c by c plus 0.85 c, that is equal to c. Therefore, the relative velocity of electron and proton is equal to c. Another example, problem number 4. The position vector of a point in the frame S dash moving with constant velocity of 10 centimeter per second along x-axis is given by 11, 9, 8 centimeters. Calculate the position with respect to the frames S if the two frames were coordinate only half second earlier. Solution: as the position of coordinates are given in the frame S dash, which is moving with constant velocity of v is equal to 10 centimeter second minus 1 along the x-axis, the position coordinates in the frame S are given by inverse Galilean transformations. Therefore, x is equal to x dash plus vt, y plus y dash, z plus z dash, t is equal to t dash. Here x dash is equal to 11 centimeters, y dash is equal to 9 centimeters, z dash is equal to 8 centimeters, and time t dash is equal to half second, that is 1 by 2 second. So x is equal to x dash plus vt. So x dash is equal to 11, velocity is equal to 10, time is equal to 1 by 2 half. So that is equal to 16 centimeters. Similarly, y dash is equal to 9 centimeters, z dash is equal to 8 centimeters. So the position coordinates of the planet in the frame S are 16, 9 and 8 centimeters. Thank you.